Good evening. Today we are going to be first revision lecture for structural analysis, and we have problems that is Castigliano's second theorem. So we know we have Castigliano's second theorem states that partial derivative of strain energy with respect to any redundant, and that is equal to minimum. And in most of the cases we have this value 0 except spring and sinking. So except spring and sinking, we have this value w by w that is equal to 0 or value is given. In that case only we have to consider this. So now we will have this problem, analyze the propped cantilever shown in figure 7 and determine reaction at B. So now we have to go for w by w VB, and that is equal to integration 0 to L m into dabba m by dabba VB into dx upon EI. Now we have this will be VB. Now we have only one region B to A, so we need not required to go for the table. If we have one region, then table is not required. We can calculate values directly. So we will consider here that is X, which is from B. So we have this will be X. Now we will find value of M. So we have M that is equal to, now we have anti-clockwise plus because we are on right of the section. So we have VB into X. And then we have minus 20x into x by 2. So this is moment at xx. But you can take this separate. Already we have seen in the class. If I will consider this as separate till x, what we will get? We have this as VB, we have this as x, and then we have this load that is 20 kilonewton per meter. We are not going to consider total load. So our total load will act over here. Value will be 20 into x, and it will act at a distance x by 2 from this xx. So we have this as xx. And then we have this will be moment. And if we will calculate it, we have VB into x minus. So we have 2 tens are 10x square. Then we will find dabba m by dabba VB because now we know m. We have to find second quantity. So we have dabba m by dabba VB. And we will get this value from this. We have VB into x, so this will be x, and as this is constant, so we have 0. And then we will put it, so we have integration now 0 to 4. Now m we have VB into x minus 10x square. So VB into x minus 10x square. This is m. And dabba m by dabba VB, we have x into x. This is dabba m by dabba VB, and that is equal to 0. So dx upon EI, and that is equal to 0. Now we will make both terms separate. Therefore, we will get integration 0 to 4. VB I will take outside. So we will have VB, and in bracket it becomes x square dx upon EI. And then we have equal to, I will say, or you can write minus. So we have this will be minus integration 0 to 4. Then we have 10x cube into dx upon EI. We have multiplied by this x to the bracket. Now we have this will be integration x square into dx upon EI. So we have this will be alpha x square comma 0 comma 4. So we have this value 21.33 x square, and then I will take this on right side, which is equal to 21.33, not x square. So we have this will be into VB. So we have this is VB. So VB, and that is equal to, now integrate it. 10x cube. So 10x cube from 0 to 4, and we have this value 640. So from this we will get this value that is equal to, therefore VB that is equal to 640 divided by 21.33, and it comes 30 kilonewtons. So VB we have 30 kilonewton, and we have to find out reaction at B only. So we will stop here only. So we can write, therefore reaction at B equal to 30 kilonewton. Reaction at B equal to 30 kilonewton. You can check it. So if we have a propped cantilever, and if we have this as UDL W, and this is L, then we have this reaction that is 3 by 8 W into L. Now if we will put it, so we will have 3 by 8, W we have 20, and L we have 4. So we have this 4 gets cancelled and 10. So we will get 30 kilonewton, means whatever value we have calculated. So this value is correct. So reaction at B we have 30 kilonewton. This is first problem. Now we will switch over to the second problem. So we have analyzed another problem. We have the proper cantilever shown in figure and determined reaction at A. Now we are again in the same way. We are going to consider this as X. And then same way, now I will directly write M we have that is equal to, if we have this as VB, then we can write M is equal to VB into X minus 40 into X. And then we have dabba M by dabba VB, and that is equal to X. Now we will put it. So in examination, you have to write actually dabba U, because we have continued with this. Therefore, I have not written over here is equal to 0 is equal to integration 0 to L M into dabba M by dabba VB dx upon EI. And now we will put these values. So we have 0 to 5. We have VB into X minus 40 X into X dx upon EI, and this is equal to 0. So we will separate out this. So we have 0 to 5 VB I will take outside, and then we have X square dx upon EI, and then minus we have 40 integration, because it is also constant, and then we have X square dx upon EI is equal to 0. And now if we will take this part on that side, 0 to 5, X square dx upon EI, and that is equal to 40 integration 0 to 5, X square dx upon EI. So you can see this term and this term we have same, and therefore this term gets cancelled, and we will get, therefore VB is equal to 40 kilonewton, and we can write, therefore VB is 40 kilonewton, and then VA we have to find out. So we will go summation Fy is equal to 0. Then we have RA plus RB minus 40 equal to 0. And from this we will get RA that is equal to 40 minus 40 equal to 0. And therefore reaction at A. So reaction at A we have 0. So that is most important. We should know the values, how we have to find out. We need not require to worry about this, how it will be. Now, if we will integrate this part, suppose we will go with this. So if we will go integration VB 0 to 5 X square dx upon EI, and that is equal to 40 integration 0 to 5 x square dx upon n. And then we will get this as integration x square comma 0 comma 5, and we will get it as 41.67. So we have 41.67 VB, and that is equal to 40 into 41.67. And from this we will get VB as 40 kilonewton. So as we have same on both sides, so we can directly cancel it and we will get these values. So we have these two problems which are in our question bank, and we will have a solution for these two problems in this fashion. So these are about your Castigliano's theorem. So we will stop here only for first lecture. For others we will see in next lecture. So thank you.